Ladies and gentlemen, I was asked to do a 5-minute presentation on ocean-going, on what we think in the ocean-going sector about the use of LNG as fuel. This is our group. We operate three different companies. One is tanker, one is bulk carriers, one is LNG and LPG carriers. These are the numbers. We have today 16 LNG vessels, large LNG vessels in operation, 14 on order. Why to select LNG as fuel? It is a suitable fuel for both slow-speed and four-stroke engines, and actually what we are operating today is both steam vessels and diesel-electric powered vessels on which four-stroke diesels are being used as the main generators. What are the pros? Of course, a reduction in CO2, a reduction in nitrogen oxides, no SOx, and very little PM. It seems to be a cheaper fuel, although from the information that we have gathered, especially in North Europe, LNG is today being sold at prices very, very close to the gas oil price. We see that we will have an advantage when we operate the engines on gas. We operate, as I said, diesel-electric vessels. What we see is that whenever an engine is operated on gas, the overhaul intervals are being extended. Problems associated with the maintenance of the engine are much fewer, but of course, to control the operation of the engine in gas is a problem that we are expecting Mr. Christopoulos, who is sitting there, to solve. The efficiency of the engines is better, and efficiency today is important. The efficiency of the same engine, if you operate on the diesel cycle with heavy fuel oil, is worse by 8–9% if you compare the operation of the engine in the Otto cycle and in gas. What are the minuses? It's a much higher capex, initial cost, to buy the equipment that is to be used basically for storing LNG as fuel, and not as much as for the equipment itself, for the engines themselves. It's a complex technology. We need additional crew training. The bunkering infrastructure for ocean-going vessels is non-existent. We are operating 100 vessels. We are not calling Piraeus more than 2–3 times a year for bunkering. The bunkering ships that we have seen up to date are very small in capacity. Of course, we have seen that 2–3 bigger vessels have been ordered. When we say bigger, we mean 8–9,000 cubic meters. 8–9,000 cubic meters may be sufficient to power a VLCC for 25 days. Depending on where we store the fuel, the LNG, we may lose quite a lot of cargo space. Cargo space is important for certain ocean-going vessels. For tankers, it is important. This is why what everybody is thinking for tankers and bulk carriers is to install the tanks on deck. Space is also important for container ships. The container ships, there has been one container ship, LNG-powered ship, delivered recently, and they lose about 400 containers to the tanks have taken the space of 400 containers. Of course, it's a special case. It's a Jones Act vessel, and their payback period is maybe less than 3 years. The lack of international standards is evident. Everybody is talking about connections, about quick-release valves, about hoses, about all the equipment that will be needed for bunkering. This is what we are doing today. We have actually ordered a VLCC that is going to be LNG ready. What we mean by LNG ready is that we have the space, we have reserved the space for 2 Type C tanks. Each one will have a capacity of around 2,500 cubic meters. We have reinforced the deck to be able to support the tanks, the LNG tanks. We have done quite a lot of pre-outfitting. We have a fuel gas supply equipment room on deck. We have got class approval in principle, so this will not be a problem. We have done the extra engineering and the design, and the total cost that we have paid for this is about $300,000 US. To proceed with this, let's say, the actual operation on LNG, we have to do the main engine conversion. Basically, it's a replacement of cylinder covers. We have to replace the diesel generator engines. Actually, today, there is only one maker of diesel generator engines that allows retrofit. All the other makers, they say our engines cannot be converted. You have to buy a new engine. We have to install the fuel supply system, the LNG bunkering equipment, additional piping, new fire suppress systems, additional fire detection, and a few other items. If you want to know the cost of a VLCC today is circa $100 million. The cost of doing the LNG conversion, the total LNG conversion is $17 million. If we did the same, the study only for an Aframax vessel, the cost of an Aframax vessel today is $55 million. The cost of the LNG conversion is $14 million. So it's a very high cost. What are the concerns? As I said, the LNG bunkering infrastructure, return on investment, the additional training of the crew. This is not a problem for vessels that are carrying LNG today because the people they know how to handle LNG. As a rule of thumb, and there have been a number of studies published on this, if a vessel is trading for less than 30% of her time in an ICA, it's not worthwhile investing in LNG or scrubbers. It's better to use gas oil from a financial point of view. How the legislation environment will develop is another issue. A hot topic today is the compliance of auto-cycle engines with Tier 3, the Tier 3 requirements. IMO have decided that the use of auto-cycle engines inside the ECAs is allowed. Unfortunately, the latest information that we have seen from several port states is that they will not allow the operation of auto-cycle engines in their area unless an exhaust gas recirculation or a selective catalytic reactor system is installed. Another problem that I see is that my estimate for the let's say for the availability of the LNG bunkering infrastructure is 7, 8, 10 years. During these 7, 8, 10 years, most probably technology will go forward and nobody will know if it will be worthwhile to retrofit an existing vessel or to build a new one. Thank you very much.